This is a rather long lecture, so I'll get right into it. It's about the DC motor. So as we saw with the galvanometer, a current carrying coil pivoted in a uniform magnetic field will begin to rotate. On closer inspection of the galvanometer design, you can reveal that the coil will rotate only until it is at right angles to the magnetic field, and then it will stop. So if we need to continue this rotation, we need to either change the direction of the, or we have to change the direction of the motion. We need to change the direction of the polarity of those north-south poles, or change the direction of the current. So this is the idea that we're going to look at here. In order to have continuous motion, we need to do a little bit more. So here's a simple idea that was used to create a motor that changes or that continues to flow, and it was with the use of what's called a split ring commutator. That's this little device here that's in pink and purple. So there are brushes here that would make contact with this split ring commutator, and then a loop here. Electricity will flow through this loop, which will cause a magnetic field. And there will be, this loop will be pushed. Let's see, if the flow is this way, so that's positive. So our conventional current flow is like this. It will be pushed up on this side and down on this side, so it'll start to rotate. Eventually, this purple and this pink part here of the split ring commutator will lose contact with these metal brushes, which will cause electricity to stop flowing. But due to inertia, the loop will continue to still move. It will then the purple will then make contact with this side, and the pink will make contact with that side. And we've essentially reversed the direction of the electrical flow. But now that we've reversed it and it's already started to turn around, it's now going to move up again on this side, down again on that side, until it splits, but inertia will cause it to continue to rotate. We'll connect again, but now the current will go in an opposite direction, and we'll have this continuous kind of motion. This is the idea behind one type of DC motor using these brushes and a split ring commutator to constantly reverse the direction of the current when we need to. The part of the motor that stays still is called the stator. That is the north-south part here, the magnetic part. The part that rotates is called the rotor, or the rotor and the stator. So write this down here, and any other notes you feel that may need to help understand that. I've described how a DC motor works for that practice question 1. You may need to kind of write that in words in an assessment you might have on this unit. This explains it further, so I will not go through this. I kind of went a little bit ahead, so we can skip through that. We talk about inertia, having it move, and this is kind of showing that split ring commutator moving. It says the conductors shown represent a loop in a magnetic field. Will the loop spin clockwise or counterclockwise? So using the right-hand rule for conductors, your thumb would be pointing to yourself in the first one. So your field lines would be pointed up there. Your thumb would be pointed down for the X. So your field lines would be pointed down. So you would have a clockwise movement in that direction. Here's another sample using the battery, the polarity of the battery, where the positive side is on the left and the negative side is on the right. Using the idea of the loop, the current around a conductor, we see that our fingers would be curling up towards the south side and curling down towards the north side, so we would have a clockwise motion. What are ways we can force this to move in the opposite direction? Well, we can change the two leads, or we could change the north-south poles, switch those around. The simple DC motor design is not very powerful or efficient though, so there are ways to improve the strength of the magnetic field in the loop and by increasing its speed. You can increase the number of loops, you can increase the current, you can include a soft core material. We can basically make this stronger, so we can improve upon this design. So here's some improvements. So here is kind of our improved DC motor. It's an armature DC motor. That armature is a core with coils of wire wrapped around it, which would turn that into an electromagnet. We have the idea of the brushes as well as the split ring commutator again. So as it rotates, we have this part where we break contact when it's at a 90 degree angle to the magnetic field. It then switches the direction of the current flow, which has it continue along on its kind of spinning cycle, and that rotation then is used for as basically our motor. So you can read through those few slides as well. I kind of just quickly mentioned it, but here are the DC motor components. We have a coil of wire, we have an armature, external magnets, the split ring commutator, and the brushes, which will only make contact when they are hitting when they have physical contact with the split ring commutator. What should the external magnetic poles be in order for this motor to spin counterclockwise? So to spin this counterclockwise, let's look. We have a positive side is the longer side of the battery, which is this on the right. That's the negative side. So we flow from positive to negative. So we have our flow here going through this way. That means that our thumb would point in this direction, which means this needs to be the south side, because your thumb points in the direction of the south. That would be the north side. Here is just a few questions. If we increase the number of loops, we would have a stronger and faster motor. If we change the plastic core to a soft iron core, if we use a plastic core instead of a soft iron core, we'd have a weaker motor. If we lower the current, we'd have a weaker motor. If we reverse the direction of the polarity of the external magnets, we would reverse the direction of the motor. I think last one here, it says, what if we reverse the polarity of the magnets and we reverse the direction of the current? Well, nothing would change there, because they would cancel each other out, those two changes. Here's some more improvements we can make. It says the magnetic force is strongest in the coil when it is lined up with the magnetic field of the external magnets. However, as the coil rotates away from being lined up with the external magnetic field, the strength of the magnetic force on the coil weakens and the motor slows down. If the motor is turned off just as it reaches the split in the split ring commutator, then it will not be able to rotate. And when the motor is turned on again, because the circuit is incomplete, you'd have to give the motor a push. So if we end up having it turned off in this sort of arrangement, we don't have any way to make an electrical connection until we actually give that motor a little bit of a push. So to overcome these issues, DC motor designers put several coils into motors and use a split ring commutator with several splits. That means the speed of the motor does not fluctuate as much. So there's multiple splits in the split ring commutator. And a segment of the multiple split ring commutator is always in contact with the external circuit, so the motor does not need to be pushed by hand to start it. So we can have a multiple split ring commutator. So this is a way to further improve our DC motor. Applications of motors, you could think of many. There's your car, but not only your car, but your starter in your car. Fans, the device needed to spin a CD or a DVD around in a drive. Some new cars now rely on electric motors for propulsion. So we have hybrid cars and electric vehicles that use electric motors as well. So while completely electric vehicles have potential to be environmentally friendly, it depends on how the electricity used to charge the battery is generated. In addition, the motors contain heavy metals, which can be toxic to living things once they're recycled. So that's another thing to consider about electric vehicles. There are some other things that are somewhat a downside when we talk about electric vehicles.